My name is Arie. I'm a product manager on Google Cloud within the cloud healthcare organization. And the title of this panel is Telemedicine, a Global Perspective. So I'm very honored and fortunate to host 4 of our partners, representatives from 4 different organizations. And I would like to share with you some aspects of the work of what our partners are doing and kind of some of the commonalities, some of the interesting idiosyncrasies of what they're seeing in their respective fields and geographies. Would love to the extent that it makes sense to share a little bit of how Google is approaching the space and how is our cloud platform and technology helps play a role in this context. So maybe we can start by each one of our participants introduce themselves and kind of the mission and the organization that they represent.
Good morning, everyone. My name is Lorenzo Rizzatto. I come from Italy. I serve as a technical director for 2 companies. One is a telemedicine, teleradiology company active in Italy. And the second one is we provide cloud services for archiving and distribution of medical images. And the name of the company is O3 Enterprise. Yep.
Hi, my name is Takashi Tochi from Mnest. We established this company in 2000 in Hiroshima, Japan. We have 2 strong points. One is network of doctors. More than 70 doctors are enrolled and work together. And another is our original system for image diagnosis. We developed that on the base of cloud, GCP. And leveraging those 2 strong points, we are trying to expand the possibility, the availability of the teleradiology as the title of this session. We are very confident that teleradiology can bring lots of merits to our society. Our society hasn't known that yet. We want to bring out its full potential. Okay.
Hi, everyone. I'm Dan Mollura. I'm the CEO of RadAid International. So we're a nonprofit organization that brings radiology to low-resource regions, developing countries. We were founded in 2008 to address the problem that radiology is missing in about half to 2/3 of the world. That means that all the medical images that are so vital for diagnosing and treating disease are mostly absent in these low and middle income countries. We have about 11,000 volunteers that go to these countries to build radiology capacity. So that might mean donating equipment, doing trainings, education for health personnel to use medical imaging in a way that can benefit the patients. A large part of what we do now is also donating the IT infrastructure and bringing in PACS and other IT infrastructures that are vital for bringing the images from the scanners over to the workstations so that they can be interpreted, which of course raises the big opportunity for long-term artificial intelligence development and other advanced IT infrastructures. So it's great work that we love doing, and it's great to be here. Thanks.
Hello, everyone. I'm Rafael, co-founder and CEO of Portal. We are a telediagnostic platform that connects clinics, hospitals, and governments. Our goal is to provide access to quality healthcare, especially in remote areas. So we develop a technology that integrates with medical devices. So the nurse, usually, or a general physician, do the exam, data is automatically transferred to the cloud, and the medical specialist, like a neurologist or cardiologist, make the diagnostic online. This result is available in the same day to our network of clients of 500 hospitals and 300 cities in Brazil and Africa. Through our proprietary data set of about 30 million patients, we train machine learning models running TensorFlow to automatically detect diseases in these exams. So wherever the ML model detects a disease, it assigns a risk score and move it up in the queue to emergencies. So this is how we do such a large scale, because we use ML to prioritize the emergence, so the doctors do the diagnostics on top of this. Our goal here in Next, we're looking for partners to help in this global expansion and in our mission to provide universal access to healthcare. Thank you.
Thank you, folks. So this has been actually a personal dream of mine to bring like people from solving a very similar challenge in different geographies and kind of trying to find like what's common and what's idiosyncratic. In my mind, I was calling it the Medical Imaging Olympics. We have representatives from 4 different geographies. So it sounds like the problem we're all trying to approach your organizations is like increasing access to quality care, right? Like, so you have expertise in one place and you have the people who could benefit from in a different place. What do you find idiosyncratic? Like, what's kind of unique from your observation and your conversations with colleagues from other parts of the world that might be unique to your geography? And we don't have necessarily to go by order. Whoever feels like they have something, jump in.
Okay. So what I see is similarities and difference. First is the matter of legislation. I believe each of us has a different scenario to operate, and especially then when people say Africa, it's not Africa. There are a lot of different countries with different regulation. Within the case of the US, it's different states. So for example, in Brazil, we have one legislation, it's federal, and with this legislation, we can do diagnostics between the states with no problem. Here in the US, there are several states that doesn't allow the license for the other states. So you need to hire local doctors, which is one of the barriers of the adoption of telediagnostics here. And also in terms of technology, I'm surprised to see that what I thought was a problem in Brazil and emerging markets, for example, interoperability, that the systems don't talk between them, and the devices also have a lot of problems at proprietary files. We are seeing similar issues happen in the US and Europe as well, for different reasons maybe, like very big vendors that don't want to integrate, as opposed to in Brazil we have a lot of smaller vendors which do want to integrate. So I see it as a matter of technical challenge in most emerging markets, as here and some places in Europe, I see more as a political challenge between these big players. But it's nice to see that we have a lot of similarities between the way that we work. And this is one of the reasons that we are using GCP, because there's some infrastructure challenges that are similar between us, and Google is helping us to solve this.
Yeah, so Rafael's right. There's a lot of heterogeneity, diversity across these locations. RadAid works in 30 countries and about 55 hospitals, so we see a lot of differences across these locations. I think the big thing that we're finding that's idiosyncratic and important to point out is that with all this technology development and the algorithms and what's coming for the future of artificial intelligence in healthcare and medicine, RadAid is here to empower the user. There is still a gap between the user, which is the healthcare professional, and the great technologies that are capable. So by empowering the user, we're talking about really retraining healthcare workers to think a little differently in their clinical practice and how they adopt technologies into their daily work. And that's something we can do by integrating things like cloud and AI into the practice of healthcare. And we're finding that that's going to require a lot of on-site work and a lot of understanding of what the uniqueness characteristics are of these hospitals and how they work in their cultures, and appreciating what that heterogeneity might be, but at the same time leveraging the great technologies that are coming from this kind of context.
Talking about a common feature of teleradiology, especially this is a very similar with the Dan's RadAid. Please let me explain about our Mongol project. Now we are proceeding a 3 years project with Mongol doctors. Every year we hold a 1-week training seminar in our office in Hiroshima, Japan, inviting Mongolian doctors. In that seminar, firstly, we teach them how to the knack to interpret, because Mongolian doctors are still a little bit behind in their diagnostic skills. So we teach them how to read, how to interpret, but rather we focus on teaching them how to use our system. That's because that's a kind of preparation for e-learning. Of course, 1-week training seminar, that's not enough to build strong skills. So after the seminar is over, they're back to their hometown, and while making diagnosis in their daily job, they consult with us via our system. Oh, doc, I think this tumor is not malignant. Do you agree or disagree? That kind of thing. One doctor told me, oh, this is a ideal platform for consultation. We can discuss seeing the same images at one time. We can do that with doctors all over the world. And not only us, but you and you. We all can do that because that's cloud. That's cloud's power, value. Teleradiology and cloud are inseparable. Thank you.
Okay, I believe that one of the main problems is standardization, as Rafael mentioned. And we have, let's say, we face really big complexities with the collection of data around the territory. And but as soon as they reach the cloud, it's all done. And we have no complex scenario to face. And of course, we also face regulation problems. As you know, in Europe, we have since May 2018 a new general data protection regulation, which is really strict, and we have to collect consents from the patients, and all the process must be audited and must be transparent. So this is made, of course, easy with Google Cloud, since the platform itself is GDPR compliant, and yeah.
Thank you, folks. So one thing I want to point out that kind of stood out to me is like one of the idiosyncrasies I remember when first learning about MNIST work is that as a data point, in the US and in Japan, you have a comparable number of medical imaging devices like CTs and MRIs, very similar, maybe 10%, 15% difference. But the number of doctors, radiologists in Japan is, I think, 7 times less. So it creates a huge scarcity for radiologists. So it's an interesting kind of dynamic that makes you realize that, okay, this resource is very valuable. I need to optimize it effectively. One thing I want to ask you, like, if I ask you, how many people have spoken to a doctor on the phone here, right? The majority of people have. So in some sense, it's like kind of a basic telemedicine, right? You're talking to a doctor remotely. So the phones have been since Alexander Bell, and internet has been around since the 80s. So what does cloud change? Like, or is it just faster internet? How are you thinking about that piece?
Well, I believe that with cloud, the time is the speed of the process is much higher, of course. So I am in the sector since 20 years, so I saw all the phases. For example, for our teleradiology projects, we used to have our own data center, and we used to move point to point all the DICOM images. So the biggest projects we had, they were mammography screening teleradiology projects. So it was really a big pain to move the images from the server to the single point, to the single workstation of the radiologist that was reporting from home, for example. So it was really a long process, and many people were involved to monitor all the workflow. And but now with the cloud, it takes some minutes. So we collect the images, we collect the priors, so the actual study plus the priors, and then they are immediately available to everyone on whatever device. they want to use. Of course, they are using multi-monitor workstations. So it takes minutes from acquisition to reporting. So this is, in my opinion, is one of the best, the most important point. And of course, there are less mistakes in the process because it's simplified by technology.
As Arie told, in Japan, the ratio of radiologists to scanners, that ratio is ridiculously low in Japan comparing with other countries. We have many, many scanners, CT or MRI scanners, but the number of radiologists is strictly limited. And last year in Japan, overlooked cancers became a social problem. Very famous, large, respected hospitals announced one after another that they did overlook. And sadly, some resulted in patients' deaths that gained nationwide attention. And as a result, as you can tell, the result is raised expectation for teleradiology. The radiologists are short on numbers, so in order to centralize and make it more efficient, teleradiology is essential, indispensable. And in that point, cloud and teleradiology is inseparable, and cloud is essential. Thank you.
Cloud brings down costs and lowers complexity. It's the basic two deliverables that a cloud can bring into a low resource environment. So for example, this past year, RadAid with Google Cloud, as well as Ombra and a logistics company, TribalCo, implemented a solution where there was a Lao Friends Hospital for Children. This was a low-resource hospital in Laos. Had no radiology department at all practically 3 or 4 years ago when we started there. Now, for them to have PACS, right, this is the architecture for sending the images from the scanners to the workstations. For them to have done that using a conventional solution, RadAid has done that. We've sent these large racks, these large servers, to places that had to build a climate-controlled server room and do their own storage, but that was very complex and very costly. Imagine a low-resource hospital having to build all that infrastructure and then have all that IT personnel within the hospital to manage it. It's a very difficult scenario to manage. So instead, the pilot we did with Google Cloud in Laos, for example, we came down with a compact server now that we could hand carry that's temperature resistant, so it didn't need any climate control at all, and had all the preloaded Ombra PACS software on board already. Went to the hospital and turned it on, connected it to the imaging modalities so that it would have on-site storage, but as well it would immediately back up to the cloud, which was the Google Cloud, which we're calling RadAid Friendship Cloud in this instance. So it overcame all of these logistical barriers that could have occurred otherwise, and then also dramatically lowered the cost. So what cloud introduces is it lowers the barrier to entry for low-resource hospitals to implement their IT infrastructure by having a way to really turnkey transfer images from scanners to workstations and then have a way to back up those images.
I'm going to share one technical example that we have. For machine learning, we use TensorFlow for the last 2 years, since the first versions. And back there, we had, I think, about 10 models, because these models are very narrow. So it's one model for a chest X-ray. We're not going to work in AKGs, not going to work in TCs. They're very specific. And every time we try to train one of those models in our own VMs, for example, it took about 5 weeks for each of these models get trained in these millions of examples. So just imagine the R&D cycle for the developers who have to wait 5 weeks, see if the model is better or not than the last version. So we've been through a program that Google has called Launchpad Studio. It's an acceleration program for tech companies last year. And our goal was to apply the continuous integration paradigm in machine learning. So the thought of continuous delivering new models. And the way that we did that, we port all the models that we have for Cloud ML Engine, which is a managed TensorFlow that you can just choose the metric and the data set, and it trained it for you. So which used to took 5 weeks, right now it's taking 2 days. So how it works? We get a data set, for example, for chest x-ray. This is one of the simplest one. We have a list of findings, nodules, TB, pneumonia, consolidation. And each of those models, instead of just one being trained in a VM for 5 weeks, we can put 100 different containers to be trained at the same time, and each of those containers have different neural network architectures, different layer sizes, and different preprocessing techniques on this. And because it's pretty much a trial and error still, deep learning, you don't know exactly what will impact if you change layers, for example. So what we do, we put these 100 containers to be trained at the same time, with just one script that called this API. Each of these containers will have a different configuration of the neural net, for example. And then after 1 to 2 days, the 100 are trained, and we collect the metrics. But instead of collecting the regular metrics of memory, latent, CPU, for example, we collect those as well. But we also collect the metrics from the confusion matrix in TensorFlow. So accuracy and recall, these are collected automatically. And the model that has the best performance go to production. The other 99 are killed, and this is started again. So each 48 hours, we retrain our whole models again with the new data that is coming from these 500 hospitals. And right now, this is happening without us having to like press any buttons. It's happening like, actually, we're doing this weekly. So every Saturday night, we train with the new data from the week. But with these variations of architectures and layers and stuff like this. So right now, and since we got this about 8 months ago, right now we have 200 different models they are running in production classifying these diseases. So this is one example of how it became scalable, and now our engineers, our ML engineers, can focus on the models itself and not in the plumbing around. And when you stop to see like machine learning work, I would say that about 90% of the work, it's the plumbing. It's like the authentication, it's data engineering, organizing, ingesting this data. And 10% is actually PhD machine learning work. And if you give these PhDs to do the other parts, to do the DevOps part, they would take like 3-4 times what a good cloud developer would take. So it's a way to speed up the ML work, which is actually usually high-paying per hour people that don't know how to do the cloud infrastructure, but they are very good at mathematics. So you keep them focused on what they're good at, and the cloud take care of all the plumbing around.
So I guess when you bring up AI and medicine or radiology, the natural questions is like, you know, what is the role that AI will play in kind of changing the dynamics between a doctor and a patient? And there is the elephant in the room kind of question, will AI replace doctors, maybe on certain specialties? How do you use AI in your organization, and what's your take on this kind of changing role of a doctor, and will AI replace or augment doctors?
Well, in my opinion, AI augments doctors. And so far in our organization, we implemented some models for prioritizing, as you mentioned before, and also to, let's say, to segment the studies in order to assign the studies to the right doctor. So, I don't know, for example, mammography, dense breast. So we are more difficult of course, to report. So what the model does is a classification of breast density, and then if the study is a dense breast, it goes to an expert radiologist. And so this is lowers the risk for the patient. In my opinion, in the future, it will be more and more. So why not? Maybe radiologists will be replaced, maybe for routine works, routine reporting, and we'll have more time to concentrate on, let's say, most difficult cases. I believe so.
Talking about AI, I want to share the ironical situation in Japan, ironical situation of approval in Japan. Through the collaboration with startup AI vendors, we have developed several AIs, and our doctors, our enrolled doctors, have used them since more than 2 years ago. And now, they know lots about AI, good and bad, its usefulness and its limits, both. But maybe we Japanese are very conservative people, and our National Health Ministry has approved just one AI by now. Many vendors have developed many AIs, but still just one approval. And on the media or among doctors, the pros and cons of AI still remains as a matter of dispute. But from the viewpoint of our doctors, the doctors with lots of experience of AI, from their point of view, that dispute seems to be irrational, one-dimensional. For example, some doctors expect too much. Ooh, AI is going to do many, many things with 100% accuracy. Or, no. Or some others fear too much. Ooh, AI is going to drive us out of business. No. My take is just give them the opportunity of hands-on AI trial as soon as possible. After a couple of weeks of using AI, maybe they know, they will realize that reality, good and bad, and that dispute would be more realistic, more down to earth. And I think that would be beneficial for our health ministry too.
This is a great question. I'm a radiologist, so I'm right in the middle of this. Is AI going to replace me, for example? Most of us believe at this point that AI is going to increase quality and increase efficiency. But it can't really replace the human caregiver. Human patients really need a human caregiver. It's the human condition. So no one's trying to advocate that machines should take over this particular role. But it can improve the speed at which we do things and the quality at which we do things. So a couple of examples have been suggested, like a basic triage role for triaging the different cases, ones that are abnormal from normal or ones that deserve immediate attention versus ones that can wait, acute disease or emergency versus something that's chronic and can be dealt with at a different velocity in the care context. So these are different scenarios that AI can deliver. But what's very true, and was just mentioned, is that AI is really not in our context yet. When I go to work on a daily basis, there is no AI that I'm aware of in my midst. But it is in the future, so we're trying to incorporate it into the vision of what the profession will have. But what's also important, though, is that once you start integrating AI into the clinical care workflow, you're really changing the way that doctor is going to do their job. And that means retraining that person for how their job is now influenced by this new capability. So it doesn't transfer very easily. It doesn't just happen overnight because that doctor is still responsible for the life of the patient. So they're not just going to hand it over. So like you just heard, only one approval of an AI mechanism so far. I mean, that's not surprising because we're talking about the fact that the human care on the other side is still at risk if that AI doesn't work. So that transfer needs to happen in a way that's careful and trained. So I think what comes from this is a great interest in education for health providers to really think about how they would use AI in those workflows.
I'm going to open with a fun quote that what is AI? Because I heard if it's reading in Python and C++, it's probably machine learning. If it's reading in PowerPoint, it's probably AI. And so we need to differentiate things. And in our case, it was a matter of adoption for the doctors because we started to trust these models, but how we approach the doctors to use it. And in our case, in healthcare specifically, it cannot be an end in itself. It needs to be a mean to something. And once we started to do a lot of daily diagnostics, we started to hit the first bottleneck, which was prioritization. So even if we give the results in same day, 24 hours can be too much, depending on the case. So we approach the doctors in a very light way. What do you think if you prioritize the emergencies? And then we run about 6 months of a dual pipeline of the predictions against a regular nurse prioritizing things for them. We have a nurse full-time that take care of this. And it was obvious that the prioritization made by ML models was being better and faster, milliseconds. And so they agreed. And then after 1 year using this, when we hit about 90% recall, which is very low false negatives, we train everything for recall first, specificity. We say, okay, now we trust enough in these models to do a double check. So if the algorithm predicts, for example, a pneumothorax that could be fatal if not treated fast, it will move it up in the queue. In seconds, you get to the radiology. But if he clicks normal, he didn't see it because you can have very small pneumothorax. Then the system sent to 3 other doctors and create a board of consensus between them. Of course, it's a blind test for all of them. They think it's the first opinion. But then with this, we could rule out this kind of mistakes. And then a data point, is not me saying, it's a study by Harvard, which is the doctor precision is around 80%. Depend of the modality, of course, but when you stop to think about it, of 100 stage 1 cancer with a very small nodule, 80 will be found, and 20 not. Probably going to be diagnostic late with a stage 2 or 3. So now, when you approach a doctor, okay, if you made a mistake, the system will send to 3 other doctors. So this kind of small things are not going to be a liability for you. And then they'll say, okay, let's try it. Same thing. We did a dual pipeline, and they started to trust the models, and now we are using this. Of those 200 models that we have, we have all of them for prioritization, and we have 40 that we trust enough to do the double check. And so it's a matter of how you approach them. And the last example is that what is the KPIs that the doctors are looking for? It's different KPIs for us as the company managing this platform, but for them, most of the times is how many diagnostics I can do per hour in a safe way. And because the unit economics need to make sense, to have good doctors on board doing these diagnostics, they need to get the same dollar per hour as they will give they will have in a hospital, in a shift in the hospital, for example. So the way to speed up these things with this prioritization and double check, and with decision trees that they click instead of type. Like, for example, a neurologist will click epilepsy, diffuse, frontal lobe, diagnose. So with this, we speed up about 10 times how many diagnostics they do per hour, but they know if they misclick something, it will happen, they do thousands per day, this will go to other doctors. So it was all a matter of how you approach them and how you show the benefit, and not the technology itself. They actually don't care if it's running in TensorFlow in the cloud or on-premise, but they need to know there is helping them to make it safe. So we believe that when you combine the doctor and the ML models, you can hit the 99% accuracy.
So lots of good ideas. One thing I would like to share from our perspective, AI is not going to replace radiology, but I think radiologists that use AI could replace radiologists that don't use AI, right? Because AI is yet another tool. It's like saying, I'm not going to use a computer, I'm not going to use digital technology, I'm not going to use the internet. It's just going to make the quality and the productivity lower level. So we think AI might be another tool in the arsenal of doctors that are helping patients. In this context, I want to, I think the topic came up, like numbers and economics and who pays for this. So I'm actually curious, so Dan, you represent the nonprofit sector, and you folks represent the commercial organization. So in your geographies, in your markets, what kind of economic trends or maybe forces you are seeing? For example, in the US, where there is the payer and the provider, and oftentimes they kind of have this interesting balance between them. Who's going to pay for this new AI service portfolio? How does it play in your markets?
This is a very interesting question. Well, to tell you the truth, for example, in Italy, the payer is usually the government. So we have a public health system, and they have really a lot of difficulties in incorporating these new technologies into their payments. So so far, for example, not even teleradiology is inside these lists of services that the government pays. So, of course, since artificial intelligence algorithm lower the risks and at the end, of course, they make you save money. In my opinion, for example, the radiologists themselves and the organizations for example, the insurances that cover the organizations and the radiologists should pay for these tools because the risk lowers.
I can't tell the financial aspect of AI, but as I mentioned, in Japan, the number of scanners are very, very many. We have many scanners, but the number of radiologists is limited. So to cover that shortfall, we need not only teleradiology, but we need also AI. I can't tell to what extent, but more or less AI will be introduced in medicine, and AI will work together with radiologists and then cover that shortfall. In that context, Japan ranks top as a country that needs AI and teleradiology both.
To answer the question about who would pay for AI, first I would put it out there for all of you to think about how exactly will AI be delivered to these clients, these medical clients. Because right now, if you think about AI coming about within PACS, well, then that means that a PACS vendor will license or build itself AI and put it into the product. Remember, PACS is a closed system. No one can just open up PACS and add new software into it. It's closed. So it goes to the client, and then they just use it as is. So essentially, that hospital would be paying the PACS vendor for whatever's in it. So they would be passing that cost through to the hospital through the price of the PACS. Same goes for hardware. If you think about CT, ultrasound, MRI, or mammography machinery, that can also embed AI within the equipment. So again, it'll be included as product advancements that then get sold to the hospitals in that kind of dynamic. Then when we think about, well, who pays for it short-term, middle-term, long-term, that's where the difference between nonprofit and private sector and public sector actually becomes very relevant, especially in low and middle-income countries. As a nonprofit, we have a much higher risk tolerance than any of the others do in private sector and government because we're mission-driven and we can afford to lose money. Right? We can go and do something for the sake of mission to put something in place because we know the patients need it. So in the short term, a nonprofit like RadAid can have a very high tolerance for that risk, whereas private sector will be very reluctant to take risk like that initially. But then once nonprofit can show that something is workable, a pilot or something is sustainable, that's where that risk kind of reduces and that return on investment becomes more palatable to private sector. And that's why it's very important to consider the private and nonprofit sector partnerships. Then as you get into the middle term, that medium term of nonprofits and private sectors partnering in that regard, that's when government really does come into play as a long-term solution. Because then you're bringing in the fact that governments are never going to get involved in that initial stuff that actually has high risk, that nonprofits can do. But for long-term, for public sector and providing public goods to the population, that makes more sense for government. So short-term, for high-risk innovation, nonprofits are well-positioned in this space. And then for short to middle term, you've got private sector partnerships. And then for the long term, you have a government actor also coming together. And that's how a lot of innovations have come into healthcare, and I would say that it's probably going to be along similar lines in this case too.
I agree with what Dan said about how AI will be delivered. I think this is the main point to think who will pay for it. And this is, in our case of healthcare, like deep linked to regulation again. So for example, here in the US, you can do teleconsulting. So there's doctor on demand, teledoc there. You talk to your doctor through a video. In Brazil, you cannot do this. It needs to be B2B, not B2C. Never a patient can call us directly. You need to go to a local, small clinic, and this clinic will then access all these specialists in the hospitals. If you follow these rules, you're doing a B2B. It can be a video call, but our main goal is exams, diagnostics on top of X-rays, MRIs, etc. Then it's fully reimbursed. So it doesn't matter if it's a local doctor or it's a remote doctor in São Paulo, the government or the insurers will reimburse a teleconsulting or telediagnostics. So the way that we did, we embedded our AI costs, our machine learning costs, per test, per report. So whatever report change hands, we receive an amount for this and the doctor get paid. And the inherent costs of GPU, these are like GPU hours or API calls, but there is a call, there is a price per test. So when you embed this per report, and then the report is fully reimbursed, then the AI cost is diluted on this. And that way, the government and the insurers are paying for. If I approach the insurers and say, pay the API call here, they're not going to understand it. But if this is embedded in the workflow, so this is why I say it cannot be an end in itself, it needs to be a mean to deliver something, then it's fully reimbursed. I do have another case where AI was this like important for us. We won a bid with the São Paulo Public Healthcare last year, and so they are acquiring the platform. And there is a price for AI, but it's not specifically on the bid say we're going to pay X amount for the AI. They were asking for like features. For example, we need probabilistic matching of patients between different systems, because different last names, so this is one of the features that they have. We need to be able to prioritize emergencies with machine learning, was one of the things. We need to be able to audit our previous exams. So they have 20 million exams for the last 10 years, and now we are running our models historically on this, and finding like cancers that was diagnostics as normal. And then we can create clusters and alerts and call these patients again. So it wasn't like a price, a tag price on this, but being able to have these features was the difference to won the bid, and then the price is the full platform. So it depends of how you deliver and legislation, of course.
So I'm hearing that it's a complex issue. We probably won't resolve it in the next 8 minutes tonight. One thing I want to ask each one of you is like, what are you and your teams are most excited about for this year? Like, what are you anticipating? What could help you accelerate?
All right. What are we excited about it? We have many projects together, Arie, so you already know the answer. But like this bid that I mentioned with the São Paulo Public Healthcare, it's one of the things. So what we did in the private sector with these 500 hospitals, it took 6 years, one by one, bottom up, and now we have this network that is connected, is running well. Now we want to take this to large scale. So we started to work with the São Paulo government. It's a pilot of 35 million citizens, 20 years. And when it works, we then take this to the federal level. So we're now kind of developing a playbook of how to speed this implementation. So what takes years, now, for example, it takes about 18 months to implement in a new network in the city. If it's a clinic, we can install now in 1 day. It used to take 1 week, 2 weeks, and now we install 1 clinic per day. But now to take this broadly and faster, we want to learn how to do a full country in 90 days. So this is our objective with Google right now. We are expanding fast to public healthcare, and it's different from the private. Like people are paying for. It's as governmental projects. It need to be very low cost to be able to be sustainable after we deliver the platform. So all this cost engineering is getting way more important right now, because we need to deliver a tool that then is sustainable without us taking care and then disconnecting all these healthcare centers. So I think right now we are shifting our minds of one by one hospitals to a more broader view of populational healthcare management, where we are applying the same algorithms that we did one by one on top of way larger and more heterogeneous data sets. And one thing that it's nice is that when you compare the metrics that we have with the top papers from MIT, Stanford, we've seen that the algorithm that they train are trained on top of the Stanford hospital with the last GE device. And when you try to apply this in emerging markets data sets with different devices, different DNAs, you're not going to generalize. You're going to lose a lot of precision and accuracy on this. And we are thrilled to see that since we trained this in different devices in 300 cities, from the top GE in São Paulo for lower tier devices, some, for example, a Chinese device or a Brazilian device. And now when you apply this in new data from new hospitals, it's generalizing very well. So one of the things is that you need to take the bias out of the data sets to be able to then apply this to different populations. And we see that our experience in the 6 years was worth it. So our goal right now is to speed up this to implement in more countries.
I'm very excited about the partnership we have for developing an ecosystem for AI developers to interface with the hospitals where RadAid serves. As I said, by building cloud architecture and building capacity in those hospitals, that creates an ability for AI developers to work with RadAid and to work with those hospitals to bring AI into existence for those hospitals. And this would be an open source system. This would be a way for developers to learn more about what these hospitals need. This would increase data diversity by bringing these hospitals into those repositories that really need to be more diverse for that AI to be accurate. So this is an important endeavor we're taking over the next year. We invite the AI development community to work with us on this. To really make this a dream come true as an ecosystem for AI development and healthcare to be together.
Now we are proceeding a project with the Google Brain team. In that project, we are developing an infrastructure to exchange images and AI result. Hospitals and clinics like us send images to Google, and on Google's side, AI scans and analyzes those images and then display the result. And very soon, we can complete it and show it to you. And as Dan mentioned to vendors, PACS vendors, I think we should change the present situation, the situation of vendor-dependent medicine. I think AI, we should use AI like other internet services, say Google search. When you type a keyword and click a button and you get the result. We can and we should use AI that way. And that infrastructure is not only for this project, but in the near future, it will be one essential part of AI diagnosis system. Our works, that infrastructure can support doctors all over the world. That's a great honor for us.
We are excited as a company for, we have some new projects on AI with the regional governments. So we are collecting data from them, and then we are developing with them some artificial intelligence tools. And so, of course, is really exciting for the company.
Thank you, Lorenzo. So just want to add on what Takashi and Dan said on the ecosystem. We definitely take an ecosystem approach. So our view from Google Cloud, we want to enable application developers to build AI applications in healthcare and radiology generally, because these applications tend to be very narrow, and it's going to take hundreds, maybe thousands of applications. We believe that it will take entire ecosystem to develop this effectively. We invest where we can accelerate this process. For example, how to develop better labeling tools or how to develop better training tools, but the applications themselves would be developed by the ecosystem. We have a minute left. So I want to ask you in 10 seconds, what's kind of your prediction for the next 18 months? Lightning round. Who wants to go first?
Okay. Actually, my predictions is the challenge that we need to solve, so I hope we fulfill this prophecy. But right now, these models they are very narrow, so they are same. Pneumonia, yes or no. Pneumothorax, yes or no. What we're trying to break now is correlating this with a lab test, for example, or with the AHR, and have a deep learning model that actually look at multiple signs to then do a proper telediagnostic, because we don't believe that only look at the image is enough, even for a doctor. So imagine the AI that don't have any knowledge of the word making predictions on top of pixels only. So we're trying to cross these barriers and create multimodality models that absorb all kinds of healthcare signals.
I think there'll be a full embrace of AI education in the clinical world, that in the next 18 months, you're going to see a lot of other medical professionals fully embracing AI education in order to prepare themselves for the next era where AI will come into practice.
In this event, Google Next, in every session related to healthcare, every speakers, every panelist say the same thing, talking about the problem of interoperability, that kind of thing, to break down barriers. I think, and now I'm very optimistic in the long run, and I think this change is this can be a transition from paternalistic medicine to patient-centered medicine, and that will be beneficial for patients. Thank you.
I see that standardization also in artificial intelligence will become more and more important. So I'm sure Google Cloud will lead the way in data labeling, for example, or implementation of AI annotation in the viewers. This is really important, and everyone is doing some private annotation or some private data labeling, but these cannot continue.